Hello everyone, my name is Aruhi and welcome to my channel. So guys, in my today's video I'll show you how you can perform object detection on your custom dataset using faster CNN model. So for my today's tutorial, we will use Pytorch. That means we will train the faster CNN model on Pytorch framework. And this is a step-by-step tutorial. So first I'll teach you how to prepare your dataset and then we'll train the model on that dataset. So guys, faster CNN model accepts data in various different format. So one of them is COCO dataset format. So COCO dataset format means for all the images, you will have one JSON file and you will store the annotations related to all the images in that annotation file. So let me show you the format of COCO dataset first, and then we will create the annotations in that format. So let's start. So this is a sample file. So here you can see this is how your data annotation looks like when you store those annotations in a COCO format. So let's understand this format first. Here you can see these first few lines are just the information about the dataset, like when that dataset is created, what are the different licenses are there, like this. So we don't need this part. The important part is, which is related to the annotation, is this: categories, images and annotations. So inside categories, you'll see all the classes which you have in your custom dataset. So in this sample example, you can see that the ID1 belongs to chair class, ID2 belongs to human class, ID3 belongs to table class. After watching this section, we can say that this annotation file have the annotations which are related to these three different classes. Okay, so categories tell you what all different classes you have and what are their class IDs. So whenever you'll see class ID1, that means we are talking about chair class, and wherever ID2 is written, that means we are talking about human class. In the same way, ID3 means table class. And in images section, you'll see the details about the images. See, under categories also you are seeing the ID, but this is a category ID. Okay. Under images, the ID 0, 1, 2 means the image ID. Okay. So the image ID 1 belongs to this image. Image ID 2 belongs to this image. Image ID 3 belongs to this image. So under images, we have the details of all the images. Now, under annotations, here we are going to have the bounding box coordinates. Object detection means we need to first we will train our model, right? And we train our model on some sort of data set. And for object detection problem, what kind of data we provide to our model? We provide images with the annotations, means the bounding box coordinates. We provide these two things to the model. So that's what we are doing here. See, here also you're saying ID 0. We are having ID 0 over here also and here also. But under category, this ID means category ID. Under images, ID 0 means image ID. And under annotation, ID means annotation ID. Okay. Here you'll see image ID 0. Under annotations, what we are doing, image ID 0 means this ID. It belongs to category ID 3. Category ID 3. Under categories, we have this. So this is category ID. So category ID 3 means table. So from the first annotation, we understand that for image ID 0, we did an annotation for table class, and this is the bounding box coordinate of it. So you'll see 4 values over here: first, second, third value in the 4 value. So to create a bounding box, you need 4 values that we have over here. And then there are some other details, but we don't need those details, so we are not discussing them. So the only thing which we want is B box, bounding box coordinate, and the class name, and this bounding box coordinate and this table class is on this image. Okay. In the same way, for image ID 1 means for this image, category ID 1 means chair, and then this is the bounding box coordinate in it. Okay, so this kind of data we need to train the faster RCNN model. So this is how we store data in COCO dataset format. So now I'm going to show you how you can prepare your own dataset in this format. Okay, so let's start. So open browser. Here write VGG annotator. Okay, VGG annotator is a tool. So this is the first link. You will click on this link. Let's open it. So when you will click on it, just scroll down and you'll see this download section. Under this download section, there is a zip file, this first link. Click on it. When you'll click on it, download will start on this side. See, now let's go to the downloads folder. So this is a download folder and this is the zip file. Let's extract it. And you'll see this folder, open this folder as well. And here, this VIA, this is a HTML file. Just click on it and you'll see this kind of screen. Here we are going to annotate the images. First, we will load our dataset on which we want to perform the annotations, and then we will perform the annotation. I'll show you now how to do that. First, from this region shape, make sure that you have selected this rectangle. It will look red. Whatever you'll select, that thing will become red. So we are selecting rectangle from here. And this project here, just provide the name, whatever name you want to give it. So let's say we want to give it a name, demo annotations. Okay, so with this name, I want to create the JSON file. And here, over here, you will upload all the images. So just to give you an idea how to annotate the dataset, so I will upload over here 7-8 images and I'll show you how to annotate them. So you'll click on add files. Yeah, here, these are the images. Let's Control A and click on open. So we have all the images over here. See, you can see here. Right? The first image you can see here and rest of the images are here. Now we will annotate it. So guys, for my today's tutorial, what we are doing is we will try to detect bus, car, truck and motorbike. So these are the 4 classes we are trying to detect. So now once you add all the files, below that you'll see attributes. Click on it. When you'll click on it, you'll see this kind of screen. So click on region attributes and here provide the attribute name. Just give obj underscore classes and then click on this plus. When you'll click on this plus, you'll see this kind of screen, and from this type select drop down. Okay, and then see here ID, description, and here it is saying to add the ID. So guys, now what is the task? What we want to do over here? That here you can see that the ID1 belongs to chair class, ID2 belongs to human class, ID3 belongs to table class. So in the same way, we have 4 classes which we want to detect in our today's class: bus, car, truck and motorbike. So for all those 4 classes, we need to provide some ID. So this task we are doing here now. So let's say ID1 tab. Under description, write the name. So ID1 we are giving to bus class. Then in next line, ID2, click a tab and here we are writing car. That means ID2 belongs to car class, ID1 belongs to bus class, and then 3 belongs to truck class, and then ID4 belongs to motorbike. Okay, so these are the 4 IDs now. After that, leave this section like this only, and then here on the image, just now we will create the bounding boxes. Make sure this rectangle is selected. Now just place your mouse over here and then press the button of your mouse and then drag it like this, and when you cover the entire area of the object which you want to detect, then leave that button. So you'll see screen like this. So in this obj classes, select the object. So this is a car, we will select car over here. Now from this section, move to the next image. So this is the next image. Again, place your mouse over here and then drag it and then select the object car. For the third also, now this is a bus, so again you place the bounding box like this, and then you can do it like this, and the object is bus, so select bus. Move to the next image. Here we have bus and here we have truck. So when you have more than one object in a single image, how to do the annotation, that is what I'm going to show you now. So first, this is our first object, select truck, and then keep your mouse here, and this is a bus, select bus. Okay, so this is how you do that. And then here also we have bus, and here we have car, and here we have truck. So now let's annotate all these three things. So select this and select the bus class, then select this and select car class, and then select this and select truck class. Okay, so now move to the next image. Here we have only one object, so let's do it like this. And then next image, here we have bikes. So here is the first bike, and then we have to annotate this bike also. Okay, and then this is our last image. Here we have truck and car on the side, so let's annotate the truck first. So this is the truck, and then we have car over here, car. So now we have annotated all the images. So guys, see, I have shown you how to annotate only few images, but in real, when you're going to work on any custom data set, so you need more images. Try to work with 200 images per class, and then according to your model performance, you can increase the dataset size. So now we have annotated all the images. Now what we want to store these annotations in the COCO dataset format. So for that, see above here you can see annotation, and under it you can see various different options in which you can have your annotations stored, right? So if you want to store your annotations in CSV format, then click on this. If you want to store the annotations in normal JSON format, then click this. But what we want to store the annotations in COCO format, so we will click here, and on this side you'll see that under downloads you'll see that file. Now let's go to the downloads again here. Now let's open it. Let me open it like this. Okay, let me arrange this file to show you proper. Okay, under images, I'm just arranging the file. I'll explain you in a bit what is happening here. Let me just arrange the file properly so that you can understand it easily. Okay, now let's try to understand. See, this is the basic information which I've told you, that when you'll create the COCO JSON format, so you'll get some basic information like when that data is created, date and everything. What we want is images, annotations, and then the categories. These are the three things which we want. Okay, so if you'll see the categories, see ID1 is for bus class, ID2 is for car class, ID3 is for truck class, and ID4 is for bike class. So categories section is done, and after that here under images section, see for each image we are getting ID and the name of that image. Okay, for every image, so we have 8 images, so we have 8 IDs, and one line is for one image. Okay, and then annotations, here we are performing the annotation part. So for the first image, see, we don't want this segmentation part. Okay, just focus on this B box part. So this is the bounding box coordinate. So this bounding box coordinate is for image ID 1. So what is the image ID 1? This. And category ID 2. Category ID 2 belongs to car class. So that means the first image which we have, that image belongs to car class, and this is the bounding box coordinate of that image. In the same way, ID 2, image ID 2 means for this image, in second image, we found a class which belongs to category ID 2. What is category ID 2? Category ID 2 is car again. So guys, this is how you can annotate your custom dataset in COCO dataset format. Now let me show you how to place the dataset exactly, what should be the folder structure, okay? Because we need training data and we need validation data. Where to place the images, where to place the annotation files so that your model can read the annotations and the images successfully. Let's do that part. So guys, for my today's tutorial, I have created this folder, demo folder. This is an empty folder right now. Now I'm going to paste a dataset folder over here, and then I'll explain you what should be your dataset folder structure look like. Okay. This is my dataset folder. When you'll open this folder, you'll see three folders: train, val, and test. You will create a dataset folder. Inside that, create these three folders, name them train, val, and test. Inside train folder, you will place the images on which you want to train your dataset. So my images are these. See, I want to train the model to detect bus, car, truck, and bike. So these kind of images I have in this folder. Okay. And I annotated all these images using this VGG annotator, and I exported the annotation as JSON COCO format. Okay. And then inside this train folder, I have created another folder with the name of annotations, and in this folder I placed that annotation file. So if you'll open this annotation file, you will see like this. See, bus ID 1 is bus, car, motorbike, and truck. Then these are the few images, these are the annotations. Like this you'll see. So training images are here, and inside this annotation folder you'll place the corresponding annotation. Now for validation folder also, see, under this val folder we have all the images, and the annotations which belong to this validation images are in this annotation folder, annotations.json. And in the same way for test folder, these are my test images, and I have an annotation folder in this also, and all the annotations which belong to test images are here. You will create 3 annotations file, okay? One for training data, one for validation data, and one for test data. First, you will upload all the training images over here and then annotate them and export the annotation file. Then after that, you will upload all the validation images here, annotate them, then export the annotation in COCO format. And then lastly, you will upload all the test images here, you will annotate them, and then you will export the COCO format annotations. Okay, so this is how you'll prepare your dataset. Now our dataset is ready. Next task is to train the model, and to train the model, first you need to set up the environment to run that code. Means you need to install all the required libraries, modules which are needed to run FasterRCNN. These are the modules which you need. So guys, first thing is I'm creating a separate environment because it is always a good practice to work under a separate environment. So I'm using Python 3.10 and I'm creating a separate environment using Python 3.10. And then using this line, I am activating the environment. Okay, let me activate the environment and just open command prompt. Open command prompt, enter in a drive where your code is. So where our code is, where we want to work. So in E drive, I have a FasterRCNN folder. See this, and here, this is my environment. So when you'll create your environment, you will see this kind of folder. So this name, see, my environment name is this. So that's why we got the folder name over here like this. Okay. So now let's activate the environment. First, we will enter in this faster RCNN folder. Okay, so here is our environment now. Write your environment name, then write scripts, and then activate. Your environment is activated. Once your environment is activated, if you want to check the Python version, let's check the Python version. So as I've told you that I have created the environment using Python 3.10. So here you can see Python 3.10. After that, see, we need to install Torch, Torch Vision, and Torch Audio. And guys, if you are using laptop or PC and you have GPU in it, then you should use the power of that GPU. And how you can do that? If you install your Pytorch compiled with CUDA, then only the GPU or GPU of your PC or laptop can be used. Okay. So in my case, I executed this command because in my PC I have installed CUDA 12.1 and then I executed this command. You will see which CUDA version you have, and according to that you will install this command. And in case you don't have GPU and you want to run this code on CPU, then you can simply install this pip install Torch, Torch Vision, Torch Audio from the official website. Let me show you how you can do that. So here just write Pytorch download and you'll see this first link. Open it and scroll down. See here, the current Pytorch version is 2.5.1, and if you have a Linux machine, click here. If you have a Mac, click here, and in my case I'm working on a Windows machine, so I have clicked on it. Now you want to install with Conda or pip, so we are installing with pip package manager, so click on this. So we are working with Python, so select this. So see here you have these CUDA versions and here you have CPU. So if you are working on a CPU, then select this and you will get a command here. Copy this command from here and paste it in your command prompt over here. Okay, you will paste that command. Let's just copy the command from here and then paste here and hit enter. Pytorch, Torch Vision, and Torch Audio will be installed and it is compiled with a CPU. It will work with CPU. But if you want to use GPU, so you have these CUDA options. So your PC or laptop should have CUDA 11.8, 12.1 or 12.4, and let's say you have CUDA 11.8 in your PC, then select this. See here you will see command like this, copy this. But let's say you don't want to work with CUDA 11.8 and in your PC or laptop you have CUDA 12.1, then select this command, then copy this command and paste on your command prompt. And if you have CUDA 12.4 installed, then copy this command from here and go to your command prompt and paste that command over here and hit enter. This is how you will install the Torch, Torch Vision, and Torch Audio. And if you don't know which CUDA version you have, how you can check that? Just open C drive, go to your C drive, and in your C drive go to program files, and in program files scroll down under this section NVIDIA GPU Computing Toolkit. Click on this, you'll see the CUDA folder, and here you will see the CUDA version. So guys, in my case I have lots of CUDA versions. This V12.5 means CUDA 12.5 is installed, V12.3 means CUDA 12.3 is installed. So these are the different CUDA versions which I have in my PC. But in your case, if you have installed a single version of CUDA, so you will see one folder over here. And if you are not seeing anything over here, that means CUDA is not installed, then you have to install the CUDA. Okay, so let's go back to our tutorial now here. So this is how you will install Pytorch, Torch Vision, and Torch Audio. And after that, you will install this pip install PyCoco tool. Why we need this PyCoco tool module? Because we are working on a dataset which is in COCO dataset format. So we need this at some point. So you will install this also. And then you will install Jupyter Notebook. How we install Jupyter Notebook? Just copy this pip install Jupyter Notebook and paste here and hit enter. Jupyter Notebook will be installed. Why we need this Jupyter notebook? Because our today's code we are going to execute on Jupyter notebook. Okay, so now I have activated the environment. So I have executed all these steps already. So what I'm doing is I'm directly opening the Jupyter notebook now, and I will show you how to perform the this training and testing part on a faster RCNN model. Okay, so let's open Jupyter notebook. So this is my Jupyter notebook. This is the demo folder which we have created, and in this folder right now we have only one folder, dataset folder. Remember we pasted this dataset folder. This is a custom dataset which have 4 classes: bus, truck, car and motorbike. Okay. Here we will create our Jupyter notebook, and new, click on new and then Python 3. This is our Jupyter notebook. Here we will write our code now. So first we are importing all the required modules. We are importing Torch, Torch Visions and everything which is required, and just write these lines and hit enter, and then we'll move to the next cell. See, we have this class. I have created this class. The name of this class is COCO transform, and the function of this class is only that it will convert all the images into a tensor. We are converting all the images to tensor. Why? Because we are using Pytorch for our tutorial, and in Pytorch, if you're using Pytorch framework, that means you need to convert your dataset into tensor before feeding that data to your model. Okay, so that's what we are doing. Image, we are converting the image into a tensor. So the role of this class is that it will provide you the images in the form of tensor, and it will provide you the target. Target simply means the class label and the bounding box coordinate. This target part we will discuss in detail in some time. Just hit enter and move to the next cell. Now we will write the code which will help us to load our custom dataset into the model. Okay, we will write a data loaders. So let's do that. For that we have this code. First we are creating one function, and this is the function. The name of the function is get COCO dataset. And these are the 2 parameters. First parameter is image directory. The image directory means where your training images are, and annotation file means the annotation file of the training images. What this function will do? This function will return COCO detection. What is this COCO detection? This COCO detection is a class in Torch Vision which help you to prepare the dataset in the format of COCO dataset. So that's why we are calling that class. We are providing our image data, our custom image data, and our annotation file. And also see this COCO transform. We are providing that class over here. Why? Because whatever images we have over here, we want to convert those images into tensor. So this is our function. Now in next line, here these are the lines for our training data, and these are the line for validation data. Let's understand them one by one. Training dataset variable we have here, we are calling this function. So using this function here, we are loading the training data. See, in dataset folder we have train folder, and in train folder we have images. So that path you're giving over here, wherever your images are, that path you need to provide over here. Let's go back to the code and see demo. This is a dataset folder. In dataset folder we have train, and here we have images. That path we are given over here. And in case of annotations, so in dataset train we have annotations folder, and inside that we have annotations.json file. This is the annotation file of training data. So let's see. In annotation file we have given the path like that: dataset train folder, inside that we have annotation folder, and then the annotations.json file. So this train underscore dataset now have the detail of our training data. Here we have the validation data. Again we are calling the same function. Here we are providing the path of our validation images. Here we are providing the path of the annotation file of our validation images. Okay. Next we are creating training data loader and validation data loader. Train loader, here we are calling the data loader function. the data loader function, it is in Pytorch. With the help of this data loader, we can load the data in batches, because when you want to train your model, you will provide the data into batches. Okay, so for that we are using data loader, and we are loading the training data. Batch size we want is 4. This you can change as per your resources, the PC or the laptop which you are using, and as per the RAM of your GPU or CPU, whatever device you are using. According to that, you will change the batch size. Shuffle to collate FN. So here we have created the training data loader, which means when we want to train our model using this train loader, we will load the data into batches. Okay. And then we have val loader. Here we are again calling the data loader class, because we want to provide the data into batches. We are loading the validation dataset. Batch size is 4. Now hit enter, and let's move to the next cell now. Once we have the script to load the data, now let's see how to use the FastRCNN model. So guys, for our today's class, what we are doing is we will pick the pre-trained FastRCNN model, which is trained on COCO dataset, and then we will fine tune that pre-trained model on our custom dataset. This is also called transfer learning, and it is always recommended to train your model like this only. Don't train your model from scratch, just pick the pre-trained model and then fine tune that model on your custom dataset. So let's do that. Here, so this is the function where I have done that task. I have created a function with the name of get model, and here the parameter which will pass over here is the number of classes of a custom dataset. So in our dataset, how many classes we have? Bus, car, truck and motorbike. We have 4 classes, so we will pass those number of classes later on. Here, first in this line, we are loading the FastRCNN model. Pre-trained true means which is trained on COCO dataset. COCO dataset can detect 80 different classes. So we are getting the FastRCNN model with ResNet-50 backbone and feature pyramid network, and we have it in model variable. Now how we want to use this model? See, in next line, model, this model, the pre-trained model, we are taking dot ROI heads dot box predictor dot class score dot in underscore features. What it means is that we want to use this pre-trained model to extract the features, the knowledge which it has, the knowledge which this pre-trained model have to extract the feature. We will use that knowledge to extract the features of a custom dataset, and then the final layer of the model we are changing as per our dataset. So this is how we work with custom dataset. Whenever you want to use any pre-trained model, what we do, we only change the final layer of the model as per our custom dataset. Okay, so that's what we are doing here. See, we are replacing the last layer of it as per the classes of our dataset. Here, when we will, right now we are creating this function. So in my next cell, when we will call this function to create our custom model, to train our custom model, so over here at that time we will provide the number of classes which we have in our custom dataset. And in features simply means the feature extraction, the features which are extracted, that we are doing with the help of this ResNet-50 pre-trained model only. Okay, so I'll show you in a minute how to do that. So enter. So here now we will call the function. See, number of classes are 5. So guys, remember in FastRCNN, 0 class ID is for background. So then bus, car, motorbike and truck, these are the 4 classes we have, plus 1. You, as many classes you have, you will add the 1 number in it, and then you will provide the number of classes. That 1 extra class is background class. So we have 5 classes: background class, bus, car, motorbike and truck. And get model. So this function we are calling here because we want to create the custom model, right? So get model, we call this model, and then we are providing our custom classes over here. That means this. Okay. And see, in get model, what you will get, when this function will be executed, what will happen? You will get a model, okay, custom model, which will have the number of classes as per your data set. So this model we will train now on our custom data set. Right now we have just written a function how we want to use the FastRR CNN model, right? So we have defined the layers, like what layers we want to use from the pre-trained model and final layer we want to change, but the training part hasn't started yet. We will provide the data also, right, to this model. So that part we will do now. So before starting the training, there are important hyperparameters which you need to define. Now we are going to define those. So okay, before that, device. What it means is torch.device CUDA. If CUDA is available, else CPU. Then we are moving our model to device. This model we are moving to device. Guys, this line is very important. Sometimes now we make silly mistake and then we get error. Always remember, if you are using GPU, okay, then you want to run your model on GPU, obviously, because the processing will be fast. And if you don't have GPU, then you will run your model on CPU. Okay, so you should move your model to the device, whichever device you want to use for the processing of training or testing your model. Okay, so if you want to use GPU, you will move the model to GPU. If you want to use CPU, then you will move the model to CPU. So that's what we are using here. We are simply saying if GPU is available, then use GPU for training the model. Otherwise, we will use CPU. So we are moving the model to that device. And then here we are providing optimizer and learning rate scheduler. Why we need optimizer? Optimizer help us to update the weight. So in any AI model, how AI model work? There are two paths, forward pass and backward pass. In forward pass, we provide data to the model and model gets training on it, and then model learn, right? And then we get some loss function, and then in backward pass, we try to update the weight, and we update the weight with the help of optimizer. So there are various different optimizers. So in our today's tutorial, the optimizer we are using is this SGD. And the learning rate, initial learning rate is this, momentum and weight decay is this. You can try to change these values and you can see what kind of results you get, okay? And then we have learning rate scheduler. Learning rate scheduler will help you to schedule this learning rate for different epochs, okay? Now let's run it. Next step is to write a function which will help you to train your model. So I have a function for that here. So guys, this is the function, and using this function, you can train one epoch. Okay. So what I'm trying to say is that the code which we are having in this function, this code is needed for each epoch when you want to train your model. Okay. So we train our model for more than one epochs, right? We train our model for 10 epochs, 20 epochs, or 30 or 200 or 500 epochs, depending upon the requirements and the complexity of our data set. We train our model for multiple epochs, right? So for every time when you're going to train every epoch, each and every epoch, this process will be followed, which I have mentioned in this particular function. Let's try to understand that. First thing is, see, these are the parameters which we are providing to this function. Model means which model you want to train. In our case, we want to train FastRR CNN model. Optimizer, we need optimizer. We have defined the optimizer over here. Data loader is needed because we are providing the data to the model in batches, right? So data loader will help you doing that. Device means you want to train the model on CPU or GPU epoch. Okay. First, we are setting our model to train mode. First, you need to set the model in the mode, whatever task you want to perform. So we want to train the model. So we are setting the model to train mode. Once you set the model to train mode, we want to provide the data set to the model, then only training will start. So that's what we are doing. So we are starting a for loop, and we have images and targets variable over here in data loader. What we are doing is, see, images means the training images. And targets, what target means over here? Target means the bounding box annotations and the class name. Okay, so images, with the bounding box coordinates and the class labels, we are fetching using the data loader and we are getting it in batches. The batch of images we are getting and the corresponding images, corresponding labels and the class names will get it. Okay. So then we are sending the images to device. So guys, here you'll see we are sending all the images also to device. The way we sent our model to device, in the same way we are sending all the images to device also. Why? See, if your model is working on GPU and if your images are on CPU, then you will get an error. So always remember the images and the model should be on same device. So if you are writing this model to device, so that means you will also write images to device also. Okay, so we have images in device also. Now let's talk about this target. So what I've told you, what is there in target? The corresponding bounding boxes and the class labels. Let me open the file over here. See these annotations, category ID and the bounding box. These two things we are having in target. And it is in the form of dictionary. So guys, this code over here is just for that. We are trying to prepare the data for the target, means we are trying to store the data, the bounding box coordinates and the category ID, the class IDs, right? So I'm not explaining this part in line by line. This is very simple. The final outcome of this entire function is this. See, processed target, you will have boxes, you will have labels, you'll convert your boxes to tensors, you will convert the labels also to tensor. Why? Because we are working on PyTorch. So if you want to train the model using PyTorch, you will convert the everything which you have, the data which you have, you will convert it into tensor, then only your model will accept it. So that's what we are doing, boxes and labels. So finally we have a list with the name of processed targets, where you will have the boxes and the labels of the images, and valid image is a list where you will have the images, right? So these two lists over here have the data. Now you will feed this data to your model. Okay, see here we are training the model. We are providing images to the model and the corresponding labels and the class IDs. Remember this process target, I've just shown you this. In process targets we are storing all the bounding boxes and the class IDs. So that's what we are doing. So to train a model, we are providing the model images in batches and its corresponding labels and class IDs. Then model will get trained, and then we will calculate the loss function. After every epoch we calculate the loss function, because then only we get to know whether our model is learning or not, right? So we get the loss function. On the basis of that loss function, with the help of optimizer, we will update the weights and in the backward pass. Okay, so this, and after that we are showing on the screen the epoch number and the loss that epoch have. Okay, so this is for single epoch. So for every epoch this process will be repeated. We will provide the data to the model in a batch, and then on that batch our model will get training. We will calculate the loss, and on the basis of loss optimizer will update the weight, and then we will show the error of that particular epoch on the screen. Okay, so this is the function. Now let's write a script to run this function multiple times. Means we want to train the model for multiple epochs. That means we want to run this particular function for multiple epochs, and we will record the loss of each epoch. So that's what we are doing. See, number of epochs. Here I'm just showing you how to run it for 2 epochs, but actually I trained this model for 50 epochs. Okay, so I'm just writing it 2 over here just to show you how the model training will work. We want to train the model for 2 epochs, then we are starting a for loop. See, here we are calling that function. train one epoch, this function. Okay, so we are calling that function, see, model optimizer train loader, because which data we want to provide to this function, the training data na. So the training data we can load through the train loader only. And then we have a learning rate scheduler. After every epoch, this learning rate scheduler will change the learning rate which we have used in optimizer to update the weights. And then we are saving the each model. After every epoch, we are saving the model. Okay, let's run it and see if it works. So we are running the model over here, and let me open the folder also. Here we are working. So when training will start, after one epoch, you will see here the trained model with this name. See, the loss after first epoch is this, and the model is saved. Now let me open it. Here you can see the model. So like this, I have trained this model for 50 epochs. Let me paste that trained model over here, and then I'll show you how to perform inference, how to test your model. This second epoch is also stored over here. Now I'm pasting these two folders. See, I've pasted this trained underscore model, and here you will see that I have trained this model for how many epochs? 50 epochs, right? So we will pick the model from here. Let's pick this model. Okay, I'm just copying this model from here because we will use this model, or from trained model only we can pick this model. Okay, so let's just go here, and I have created another folder with the name of test images, and I've placed this image in it, and we will perform the testing on it. So let's write the script for that. So here we are writing the script for that. So what we have done, see, this is the same get model function. Number of classes are 5. We are sending the model to device. Here in these 4 lines, see, from trained models folder, we are loading the model which we have trained, one of the trained model. And this is how you load the trained model. And then we have this function, prepare image function. So we will use this function whenever user will give some image to the model to perform testing on it. First, we need to, arrange that image in the format which your model will accept. So that's what we are doing. We are getting the image, we are converting the image into tensor, right? And then we are sending that image to device where our model is. And see, this is the image. In my test images folder, we have test.jpg file. We are using the prepare image function on that image. Okay, then this image we are providing to the model. Model will give you prediction. So these are the different classes we have, right? Then with the help of draw boxes function, we are plotting the bounding boxes and the class IDs on the test image. Let's run it. See here. See, cars are getting detected. This truck is getting detected. Motorbike is getting detected. Okay. So this is how you can perform object detection on your custom dataset using FastRCNN. So the link of this code is given in description section. You get that code and you can try it. And I hope this video is helpful. So guys, if you like my content, please like, share and subscribe my channel. Thank you for watching.